This is the review video for Algebra 1, Module 15 on factoring. Our first question, we're factoring. The first thing we look for is a GCF. In this case, since the a value here in front of the x squared is a 1, and they all don't have a variable, there is no GCF. So then I look at how many terms I have. Since this has 3 terms, 1, 2, 3, this is a trinomial, and we work on our Siena hat. So we're going to go our first number times the last. So 1 times 21 is 21. And I need factors of 21 that add up to 10 because that's our b value, the one in the middle. So we need to go through our list of factors of 21. So we've got 1 times 21, which won't add up to 10. 3 times 7 is 21. That does add up to 10. So that's my winning pair. So since this one does have that a value of 1, we can immediately go to our parentheses for answers. To get to an x squared, I know I'm going to need an x times an x. My factors are 3 and 7. Doesn't matter which parenthesis you put either of them in. And since they're both positive, that means plus signs. So x plus 3 times x plus 7 is the answer. To fully check this, you would FOIL it and make sure it got you back to the beginning. Question number 2, we're still factoring. And again, no matter how many terms you're given, the first thing we're going to look for is a GCF. So I need to see if there's a number that 112 and 63 is divisible by. One thing I tend to do is look at the smaller number and think of some of its main factors and see if the bigger number is divisible by them. For example, 63, to me, I think of 9 and 7. So if you type 112 divided by 9 into the calculator, you'll discover that that's not a factor. So then I would check 112 divided by 7, and that one does work. 112 divided by 7 is 16. So the GCF doesn't disappear. We need to bring it on the outside. So 7. Start our parenthesis and write what's left. 112 divided by 7 is 16. Bring along the x squared. Bring down the minus. 63 divided by 7 is 9. Now, I've done my GCF, but now I need to see if it can be broken down even further. So now I look at the number of terms with just 2. After the GCF, the only other way to factor 2 terms is if it's a difference of squares. So we first look for it to be a difference, meaning subtraction, and then I look to see if I can break my numbers equally apart. Well, 16x squared, 16 is perfect. 4 times 4, x squared becomes x and x. 9 is perfect, it switches to 3 and 3. So since it was a minus sign, since we could break both numbers apart as perfect squares, that means we're going to have 2 parentheses, a 4x and a 3 in each. Now the only way to get back to that difference is to have different signs. So 1 is plus, 1 is minus, and then we can't forget that GCF. So here's my final answer. Again, to check your work, you would FOIL these 2 parentheses and then multiply the 7 to each term that's left, and that would get you back to 112x squared minus 63. Question number 3, we're still factoring. So again, our first thing to look for is the GCF. So 20, 22, and 12 are all divisible by 2. So I'm going to bring that down. They all don't have a variable, so 2 is the only thing we can take out. And then we write what's left. 20 divided by 2 is 10. Bring along the x squared. 22 divided by 2 is 11. Bring along the x. And 12 divided by 2 is the minus 6. So now we look at how many terms I have here. I have 3. 3 terms means we're going to use our Siena hat. multiplying the first times the last. So 10 times negative 6 is negative 60. And I need factors of negative 60 that'll add up to the middle term, which is 11. So now I need two numbers that will multiply to a negative and add to a positive. Well, if they're multiplying to a negative, that means one is positive, one is negative. And these factors would be 4 and 15. But since the 11 is positive, the 4 has to be the negative one and the 15 positive. So now I'm going to circle my GCF and draw the arrow to remind myself to bring it down. I don't want it to get in the middle of my work. Since this a value is not 1, we have to do the longer steps. So we bring down the 10x squared. And we separate the 11x into its two factors. Since one of them is negative, we want to put the negative first. So 10x squared minus 4x plus 15x. And then bring down the minus 6. So now that we have 4 terms, the entire purpose of 4 terms is so that we can group. So we group the first two parentheses of terms and the second two, leaving that plus in the middle. And now we start in the first parenthesis and we look for the GCF. So 10 and 4 are both divisible by 2. And they both have an x attached, so they're both divisible by 2x. And now we write what's left. 10 divided by 2 turns into a 5. I started with an x squared. I took an x away, which leaves me with an x minus 4 divided by 2 is 2. I had 1x. I took that x away, so we don't have any x's left. Now I look for the GCF of the second parenthesis. Well, 15 and 6 are both divisible by 3. The 6 doesn't have an x with it, so I can't pull out a variable. So now I write what's left. 15 divided by 3 is 5, bring along the x. 6 divided by 3 is 2. And now our goal is that this and this parenthesis match. If that works, then we did this correctly. Well, these match, so there's my GCF. And then I bring along the terms that are attached to it. To this case are 2x plus 3. Now this one had a GCF way at the beginning, so we do have to bring that along with our answer. So this would be your final answer. Number 4 says the area of a square lawn is 25x squared plus 40x plus 16, and we want to know the length of one side. Well, anytime they tell you area and they ask you to find the length, we can go into factor. And it tells me also that it's square. Well, I know that a square, all the sides are the same, which means my two parentheses should turn out the same as well. And I can use that to help me think of my factors. So we've got 25x squared plus 40x plus 16. First, I'm going to look for a GCF. Well, 25 and 40 can be divided by a number, but not all three. So I need to do C and a hat. So 25 times 16, which is 400. I need it to add up to 40x. Well, since I know that my parentheses need to be the same at the end, I know that the only way that happens is when the factors are the same. So I need to figure out what number times itself is 400. Or in your calculator, you could take the square root of 400 if you don't know what that is. And that ends up being 20. So 20 times 20. So now we bring down 25x squared. Split the 40x into 20x plus the other 20x. and then bring down the plus 16. Again, the whole point to write it in 4 terms is so we can group it 2 by 2. And now we look for the GCF in each parenthesis. In the first parenthesis, I've got 25 and 20, which are both divisible by 5. And they each have an x, so I can also take an x out. And then we write what's left. 25 divided by 5 is 5. If I have x squared and I take an x away, I'm left with 1x. Plus 20 divided by 5 is 4. Had 1x, but I took it away, so there's no more. Bring down the plus from the middle. And now 20x and 16, this time they're both divisible by 4. 20x divided by 4 is 5x. 16 divided by 4 is 4. Again, we check for this matching parenthesis. It's there, so we bring it down. And then the second parenthesis is combined by what's left, which is the 5x plus 4. That's in purple. And it's asking us what's the length of one side. Well, you know, both sides are 5x plus 4 and 5x plus 4. So one of the sides is simply 5x plus 4. So here we have, again, factoring, pretty much what this whole test is going to be about. Well, with factoring, the first thing we look for is a GCF. Well, what does this term and this term have in common? They both have an x minus 6, which means that's the GCF, so we bring it down. And then we look for what's left. Well, if I take out the x minus 6 in the first one, I have a 5. If I take out the x minus 6 in the other one, I have a minus 2x, which means that's the part of my other parentheses. And there's my answer. Pulled out the GCF and wrote what was left. Number 6, we're asked to find just the GCF of 9y squared and 3y to the 4th. So it's not asking us to factor, just GCF. So once we find out what they have in common, we're done. Well, I have a 9 and a 3, and they're both divisible by 3. So I know I can take that out. And then I'm going to look at my y's. Well, the 9 has 2 y's, so y times y. And the 3 has 4 y's, so 1, 2, 3, 4. So the question is, how many do they both have in common? So I can take out 1 pair, 2 pairs. So they have 2 pairs in common, which is y squared. Since it said the word GCF and not factor, I don't need to write what's left, so this is my final answer. Number 7, so we have the brass section in a marching band with 36 trombone players. And 64 trumpet players. And the band director wants to arrange them in equal rows and that have as many as possible, so we want to go as big as possible. However, all the musicians in each row must play the same instrument. So how many rows will there be? So we have to figure out what number can I divide both 36 and 64 by. And since they said they wanted as many as possible, we're looking for the greatest number that goes into both of them, which is the GCF. Well, 36 and 64, the GCF would be 4. So if I put 4 players in a row, that means in the trombone, we have 9 rows of trombones, 36 divided by 4. (64) divided by 4 would be 16. But it says how many rows will there be with both instruments combined, so we add these together, and I get 25 rows of chairs are needed if I put 4 in each row. We also had 2 of these back from lesson 15.1. if you want to see how those were worded out of the workbook. So here we go at number 8, we're back to completely factoring. So again, first thing we look for is GCF. So we have 14, 36, and 12. Well, 36 and 12 are divisible by 4, but 14 is not. So we have to go smaller or a completely different number. But they are all divisible by 2. So then I look and see if they all have a variable attached. They all do. So the 14 has 3 y's. The 36 has 2. And the 12 has 1. So I look at how many they all have in common, which is 1 pair. So the GCF is 2y. So that's what we're going to divide each term by. So I write the GCF, and then we start our parenthesis and write what's left. Well, 14y cubed divided by 2y. 14 divided by 2 is 7. You can look and see that we've got 2 y's left, so y squared, plus 36 divided by 2, well, that's 18. And you can look and see that we've got 1 y left. And then 12 divided by 2 is 6. And you can see that there's no y's left there. Well, once I factor it by the GCF, I then need to look at how many terms I have. Well, I've got 3 terms, so trinomial, which means we're looking for C and a hat here. So we've got 7 times negative 6, which is negative 42. And it has to have factors that add up to 18. So 42, let's start. I'm going to write a list here. I know 1 times 42, but that can't combine to 18. I've got 2 times 21. Well, that's close, but that's 19 if I subtract them, not 18. It is divisible by 3. And that's 3 times 14. That's close, but that would combine to be a 17 if I put them together. Check 42 divided by 4. That doesn't work. 42 divided by 5 doesn't work. 42 divided by 6, that's 7. And 6 times 7, well, 6 plus 7 can't combine to 18 if I add or subtract them. Well, there's no other factors of 42, so that means this one can't be factored any further. So all it had was a GCF. For number 9, it's talking about a lawn that's being covered, which deals with its area, and it's rectangular, which means the length and width will be different. It has an area of z squared plus 3z. And it says to factor it to find possible expressions for the length and width. So first thing I look for whenever factoring is what do they have in common. And you'll notice the first term has 2 z's. And the second term has a z attached to that 3, which means they do have one set of z's in common. So that's my GCF, so I take that z out. If I had 2 z's and I took this one away, that means I'm left with 1. The second one doesn't have any left, so it's just the 3. So this means that the length, I would say, is z plus 3, and the width would be z. If you switched it, it really doesn't matter. Each measurement just represents a possible expression for your length and width. To determine whether 9s to the 6 minus 49q to the 6 is a difference of 2 squares, we have to look at our different reasonings. The good thing is it's a binomial. The second thing is we look for whether it's a plus or minus. It's a minus, so that takes care of the difference. And now we need to make sure the first term is perfect, a square, and the second term is as well. Well, 9, we've seen that quite a bit. We know that can be broken into 3 and 3. So s to the 6, can I break that apart equally? Well, remember, exponents have different rules than regular numbers. When we are multiplying bases, we actually add their exponents. So I have s to the third and s to the third, because s to the third times 3s to the third would make 9s to the 6. So then we've got 49. Well, that's going to be 7 and 7. And q to the 6, well, we already learned how to break down s to the 6. So q to the third, q to the third. So is it a difference of 2 squares? Yes, because I can break them both down and there's a minus. So it is a difference of 2 squares. And it says if it is, to go ahead and factor it. So we know we're going to have 2 parentheses. We're going to have a 3s cubed in each, and a 7q cubed in each. And because we have to get back to a negative 49, we need a plus and a minus. In number 11, they give us a 4-term expression, and they want to know when we group the first two and then the last two, what do they have in common? So in other words, what is that parenthesis that should be the same for both? So we have x cubed plus 3x squared plus 6x plus 18. Group the first parenthesis, we have x cubed and 3x squared. Well, they don't have a number in common, but they're both attached to x's, so I can take an x out. In fact, I can actually take out 2, because this one has 2 and this one has 3. So when I take out 2 x's from a x cubed, we're left with 1x there, and then just plus 3 here. Second parenthesis, 6 and 8 are both divisible by 6 and 18 are both divisible by 6. The 18 doesn't have an x, so I don't have to take that out. 6x divided by 6 is x. 18 divided by 6 is 3. Do they have this in common? They do. It's exactly the same. So the answer would be x plus 3. That's your common binomial factor. So this one tells us we have the volume of a box. Well, volume of a box is V equals length times width times height, 3 measurements. And they give us a trinomial, and they want to know what is a possible expression for the length and width of the box if the height is 7x. Well, they're telling us this is something that we can take out from here. Okay, so I'm going to put a 7x and divide each of those terms by 7x to find out what measurements are left after that height. So 42 divided by 7 is 6. X cubed, take away an x, is x squared. 231 divided by 7 would be not 2, 3, 33x, take away an x from x squared, plus 105 divided by 7 would be 15. Now, yes, they still have something else in common, but they're telling us that the 7x is already one of our dimensions, so we have to use this to come up with the other two. So even though they have something in common, we still are going to use this to do our C and a hat. So we're going to go 6 times 15, which is 90. And I need factors of 90 that add up to the middle, which is 33. Well, hopefully one of the most common factors of 90 is 3 and 30. And that adds up to 33. So the 7x we'll worry about at the end. So we've got 6x squared. Break apart our 33x with 3x and 30. And then bring down the plus 15. So So now we need to group the first two and the last two. In the first parenthesis, 6 and a 3 can both be divided by 3. And they each have an x, so we're going to take that out. 6x squared divided by 3x is 2x. 3x divided by 3x is 1. Second parenthesis, we've got 30x and 15. I can take out a 15 from them. And I'm left with 2x plus 1. So one of the factors would be 2x plus 1. And the other one would be made up of 3x plus 15. And then, of course, we've got the 7x from the beginning. So I'm going to say this one would be the length, and this one would be the width. But again, if you switch it up, it really doesn't matter because they're asking for the length and the width. So number 13 asks us to factor the expression 192 x to the 7th plus 375 x to the 4th y cubed. Well, again, anytime we're asked to factor, the first thing to look for is the GCF. So we're looking at what number they both have in common. These are numbers we don't see as often, so you can do a couple of things. One is you could list the factors. So for example, 192 is 1 times 192, 2 times 96, 3 times 64, try dividing it by 4. We've got 4 and 48. We know it's not divisible by 5, so we can check 6. We've got 6 and 32. We go ahead and check 7. Doesn't work. Check 8. 8 and 24. Let's see, next we've got 9. 9 doesn't work. I know 10 won't. Checking 11 doesn't work. 12 and 16. We're almost done checking. So 13 doesn't work. 14 doesn't work. 15 won't because it's not a 5 or a 0. So then I'm back to 16. So there's my list. Checking 375. We have options. We could divide all those and see which one's the highest one. Or I'm just going to go ahead and list them. So 1 times 375. I knew 2 won't work because it's odd. Dividing by 3 is 125. Checking 4. Doesn't work. 5 becomes 5 and 75. Checking 6. 6 doesn't work. Checking 7. Doesn't work. Checking 8. Doesn't work. Check 9. That doesn't work. 10 won't work because it's not a 0. So checking 11. Doesn't work. 12. Doesn't work. 13. Doesn't work. And again, to check, I'm just dividing them by it. 14 didn't work. So then dividing by 15 is 15 and 25. Checking 16, doesn't work. 17, doesn't work. 18, still not working. 19, doesn't work. I know 20 is not, because it's not a multiple of 20. So checking 21, nope. 22, doesn't work. 23, doesn't work. And the last one to check is 24. Doesn't work, because now we're back to the 25, which we already had. So now, looking for the ones that are the same. 3, and that's it. So 3 is the highest GCF of the numbers. So I'm going to be taking a 3 out. Now I look for my variables. Well, the first one has 7 x's. So 1, 2, 3, 4, 5, 6, 7. The other one has 4 x's, which means they've got 1, 2, 3, 4 x's in common, so x to the 4th. The first term That's it. There's no other variable. The second term has y's, but since the first term doesn't have any, they can't have that in common. So now we write what's left. Well, 192 divided by 3 is 64. You can see from the list that after I took out the 4x's, we had 3 left. $375 divided by 3 was 125. There weren't any x's left after I took out the 4, and we didn't touch the y cubed, so we bring that down. Now, since this is a binomial, the only other way to factor a binomial is if it's a difference of squares. Well, right away, I've got a plus sign, which means the GCF was the only possible thing I could factor, so this is my answer. 15, it says to factor. If I look at the terms, they all don't have something in common. So then I look at the number of terms. There are 1, 2, 3, 4, and every time I have 4 terms, we automatically group. So we group the first 2 and the second 2, and we look for the GCF in each. The first expression, 2 and 10, can be divided by 2. We have x to the 4th and x cubed, so that's going to have 3 x's in common. And now we write what's left. 2 divided by 2 is 1. X to the 4th, take away 3 x's, you have 1 left. So 1x, which is just x. 10 divided by 2 is 5. We took away 3 x's, so there's none left. Now the second parenthesis, they don't have anything in common. There's no number they can both be divided by. This doesn't have an x. And whenever that happens, we take out that placeholder of 1. Well, dividing by 1 doesn't change anything, so this is x plus 5. Again, every time we group, the goal is to have that GCF, that binomial that they both have. So we bring that out front, and we write what's left. What's attached to the first parenthesis, x plus 5, is 2x cubed. What's attached to the second one is this plus 1. And there's my answer. 15, again, we're factoring. This time, I see that I have a negative in my leading coefficient, my a value. Well, I'm not allowed to have that. So I know that when I take out a GCF, if there is one, it has to be a negative. And if there's not one, I have to divide everything by a negative to make that a value a positive. Well, 4, 11, and 20 have nothing in common, so all I'm taking out is a negative 1 and writing what's left. Well, negative 4x squared divided by negative 1 is a positive 4x squared. Positive 11x divided by negative 1 is a negative 11x. And then positive 20 divided by negative 1 is a negative 20. So now that I've taken out that negative, I now look at my number of terms. I have 3 terms here, which means we're going Santa hat. So we have 4 times negative 20, which is negative 80. And I need those factors to add up to negative 11. Okay, so we're looking for factors of 80. And since it's a negative 80, one's going to be positive, one's going to be negative. And the factors that are going to work are going to be 16 and 5. Well, since my 11 is negative, I need the bigger one of these two to be the negative one. So the 16 will be negative. So now the negative 1 I'm going to bring down at the end. So I have 4x squared. I'm going to put the minus 16 first and add an x to it. Plus 5x minus 20. Every time I write it in 4 terms, the whole point is to group the first 2 and the last 2, and then look for GCFs. The GCF of 4x squared minus 16x would be 4x. Dividing them both by 4x, the first term would just have an x left since 4 divided by 4 is 1. The 16x divided by 4x would just be a 4. Second set, 5x and 20, I can take out a 5. 5x divided by 5 is x. 20 divided by 5 is 4. Again, I know I did this right because these parentheses match. So I bring that out front. And then the second parenthesis is made up of its parts, so 4x plus 5. And then don't forget what we said we were bringing down, which was the negative 1. However, the 1 doesn't need to be there. We really just need to have a negative sign to show that we had a negative leading coefficient that we changed. So for question 16, it talks about a square piece of fabric, and it says the length of each side is cx plus d. So it just means we need to factor it and get rid of that exponent. Well, I know it's going to be a square, which means my parentheses are going to be the same. So I'm factoring 9x squared plus 30x plus 25. There's no GCF here, so we go 9 times 25, which would be 225, and I'm looking for factors of 30. Well, the fact that they called this a square means I know for sure the factors have to be the same. Well, the same factors of 225 would be 15 times 15. Take the square root of it on your calculator. And I know that 15 plus 15 is also 30. So I have 9x squared plus 15x plus 15x plus 25. Now that I've written it as 4 terms, so we group the first two and the last two. 9 and 15 are both divisible by 3. They each have an x, so we bring that down. 9x squared divided by 3x is 3x. 15x divided by 3x is 5. Second parenthesis, 15x and 25 have a 5 in common, and that leaves us with 3x plus 5. So I've got my matching parenthesis, 3x plus 5, and the pieces that were attached to it, which are also 3x and 5, which should have happened because we knew that it was a square, so they had to be the same. So I know that one of the lengths of the square is 3x plus 5. Well, it doesn't ask us for the side length, it talks about perimeter. So perimeter of the square is length, 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 and there's 4 of them. So I need 4 of these. So I'm going to multiply that 4, and I get 12x plus 20. So here's my perimeter. And then the last part of this question says, find the perimeter of x is 3. So instead of 12 times x, I'm going to go 12 times 3 plus 20. 12 times 3 is 36. Add 20 to that. Tells me my perimeter is 56. So 12x plus 20 and 56 are the two answers for question 16. So number 17, they've factored the expression for us, and they're asking if they completely factored it. And if not, they want us to continue factoring it. So they took out the GCF, so now we have to look at what is left. And we have a trinomial that's left. So a trinomial, we need to see if we can factor it using our Santa hat. So we have 1 times 9, which is 9, and I need those factors to add up to negative 6. If I can find a combination, then this is not completely factored and we need to keep on going. So I need factors of a positive 9 that add up to a negative 6, and that will be negative 3 and negative 3. So I know that I can break this apart into my two parentheses since a is 1 here, and I would have y and y, minus 3, and I would bring down the GCF of 3y squared. So here's one way that you could write this, or hopefully you're noticing the parentheses are exactly the same, which means I can write the parenthesis once and put a square above it and bring down the 3y squared. And there's the completely factored form for number 17. Question 18, we're factoring completely. So again, GCF is really crucial here. I've got a 50, a 165, and a 135, which means I'm probably looking to divide them all by 5. Now, if I look at the variables, an x squared y, an xy, and a y, they each have a y, so I can take that y out. So 50 x squared y will leave me with 10x squared. 165xy will leave you with 33x, because the y is taken out. And then 135 divided by 5 will leave you with 27, and that y comes out as well. So now, since we have a trinomial, we're looking for c and a hat. So 10 times 27 is 270. So we're looking for factors of 270 that will add up to negative 33. These factors are a little bit harder to find. So again, you would go 1 times 270, 2 times what is 270, 3 times what, and so on until you find a pair. And the pair is going to be 15 and 18. In order to multiply to a positive but add to a negative, they both need to be negative. The GCF, I'm going to bring that down at the end. So I bring down 10x squared minus 15x minus 18x, and then bring down the 27, or c. The point of 4 terms is to group. So I'm going to group the first two and the last two. Now we look for our GCFs. 10x squared minus 15x, there's a GCF of 5x. 10 divided by 5 is 2. I have an x left over. 15 divided by 5 is 3. Now, I've got a minus here, and every time I have a minus in the middle, this sign is going to become the opposite. So 18 and 27 are divisible by 9. And I'm left with 2x, change the plus to the minus, and 27 divided by 9 is 3. So now my parentheses match. So I rewrite that. Bring down the other parts, 5x minus 9. And then I've got my GCF that has to come down, which is 5y. And there's the factored form of our expression. Number 19, we have another completely factor one. This one's going to be a little bit different than what we've seen, but it's okay. We can work through it. First of all, we look for a GCF, and 16 and 256 are both divisible by 16. So I'm left with m to the 4th minus 16. Well, now I have a binomial. The only other way to factor a binomial is if it's a difference of squares. Well, here's my minus sign for difference. M to the 4th can be broken apart into m squared times m squared. 16 can also be broken apart into 4 and 4. So my two parentheses would be an m squared in each, a 4 in each, and 1 plus and 1 minus. And then don't forget we do have that GCF. Now typically at this point we would be done. But if I look at my second parenthesis here, m squared minus 4. Well, that's still a binomial. I've got a minus. The m squared can again be broken into m, and the 4 can be broken into 2 and 2. So this one actually becomes m plus 2 and m minus 2. And now I'm going to bring the other parts down. 16 m squared plus 4. So this one actually could be factored 3 different times. GCF, difference of squares, and then difference of squares all over again. Number 20 is another, is it completely factored? And if not, what other factoring can occur? So they took out an x, and now the question is, can it be factored any other way? Well, I see 9 and 81, and I know that 9 and 81 are both divisible by 9. So they should have taken out just not just an x, but a 9x. So 9x squared divided by 9, because they already took out the x, so that's x squared. 81 divided by 9 is 9. And now the question is, can I factor x squared plus 9? Well, x squared and 9 can both be broken down equally, x and 3 and 3, but what's holding us back is there's a plus sign here. Don't let that trick you. Remember, in order to have it work, it has to be a difference of squares, and that is not a difference. So yes, it could be completely factored, but only by taking out the number 9. 21, last question here. So we're given a rectangle with the trinomial of 5x squared minus 14x plus 8 for the area, and it asked us what is a possible dimension for the rectangle, which means we need to factor this. So if I look for a GCF, I'm not going to find one, so we immediately go to Santa Hat for this trinomial. 5 times 8 is 40. Find factors of 40 that add up to negative 14. Well, to multiply to a positive but add to a negative, they both have to be negative, and we're looking at negative 10 times negative 4. Bring down our first term here. Split our negative 14x up into negative 10x and negative 4x. And then bring down our plus 8. Now we start grouping. First set of parentheses, I can take a 5x out. 10 and 5 are both divisible by 5, and they have an x in common. And that's going to leave me with 1x, or x minus 2. Again, I've got that minus in the middle, which means this sign here is going to change. 4x and 8 are divisible by 4, and that turns that into x minus 2. I've got my matching parentheses, so bring them down. Bring the leftover parts, 5x minus 4. So a dimension of the rectangle is either x minus 2 or 5x minus 4. Either answer would be acceptable.